Thank you so much for giving us the chance to share our thoughts here in such an amazing platform. I myself, Aditi Dhali, on behalf of my team, am presenting our paper. I have Shurmishta Sharna Gomosta as my team member and Mohammad Mushfiq Anwar as our supervisor. We are from Jahangirnagar University, Bangladesh. I have categorized my whole presentation in some categories. Here comes the outline of my presentation. Firstly, some brief of our motivation and contribution. Then a discussion of our algorithm. Finally, there are also experimental evaluation. In recent decades, different aspects of human life have been affected by the digital world as an internet technology has advanced. Many activities such as communication, security, commercial trade, marketing channels, spread of information, and diffusion of news has been changed into new shape. Like other social media, Twitter has become one of the largest and most popular microblogging sites on internet. After Twitter has been launched, researchers focus on a large-scale dataset to develop methodologies on how to make this social site as a wide marketing platform. There comes the idea to find out the influential users who can help in the marketing of the product they feel interested in. Influential users also affect diversely on social topic. Our proposed approach is basically the extension of Twitter rank method by incorporating the temporal factor. We first apply the Twitter LDA topic model on the tweets published on the Twitter users to extract the hidden topics discussed by them. Then we find trending topics in a specific time period and rank those topics. After that, we apply the modified version of Twitter rank algorithm on the processed tweets to list the top ranked influential users for a given query consisting of a set of those trending topics. We also observe the changes in the rank list over time by emphasizing users' most recent activities, for example, publishing tweets in Twitter and their connections. Here we discussed about the state of an art on the base on some approaches. There are some framework based on interaction frequency entropy. This approach depends on direct indirect following links, entropy computation. Some of other approaches focus on topical interest, which parameters are single topic specific query, topic similarity, and link structure of user's account. For example, in 2010, Wang proposed a method named TwitterRank to measure users' topical influence in Twitter. And the third approach works with the behavior pattern of an user. The parameters of this approach is age connectivity and the concepts of followers network. But most of the existing approaches paid less attention on the combination of analyzing and trending topics and temporal factor, which greatly affects the ranking of the influential users. Our approach is defined to find influential users for a set of trending topics on list the topic influential users at different specific time intervals. To present our contribution, we can say that firstly, we suggest a method to discover trending topics at each time interval. Secondly, we show how users' topical influence change over time by considering the temporal factor. And we worked on a real dataset to demonstrate the efficacy of a suggested method. In order to understand the concept of the proposed method clearly, we need to learn some preliminary knowledge. Here are some basic concepts. First come social graph, which is denoted by G, and it has three attributes U, E, and A. Here, U represents set of users as nodes, E represents the set of directed links representing following relationship as ages, and A is the set of topics discussed by user G. For example, if any new topic A is discussed by U naught, that is a subset of U, then it means spread prediction of M in G and it finds the list of expected recipients users of topic A. The next one is topic. Topic represents distribution over words for a certain concept. For example, in case of sports, topic it may have words football, cricket, etc. or health topic has words hospital, pandemic, etc. Third concept is about activity. Activity refers to the certain action performed by user at a time. We can represent activity tuple by three parameters: u, psi, and t, where psi is the top trending topics covered by action performed by you at time t. Then, a trending topic is a theme that meets an overflow of popularity, often advancing around popular occurrences. For example, celebrities' announcement, social event, breaking news, etc. for a limited span of time. Query is an input, contains a set of query topic, psi. In a nutshell, problem definition is that a social graph G is given an input query queue contains a set of top trending topics, a time interval set I. The task of TTUID, that is our proposed method, is to return a list R of top R influential users at each time interval IK. This is the stages of our proposed framework named Influential User Detection Approach. Firstly, the pre-processing is performed to remove irrelevant data from the social stream. Secondly, we apply topic model method on the cleaned data to identify the latent topics. We apply our formula for ranking the top K trending topics over a specific time period. Finally, we develop algorithms and apply those algorithms on the processed social streams along with the social network graph G in order to find query specific influential users. We have applied Twitter latent Dirichlet allocation, Twitter LDA, for our topic distribution. TLD is an effective extension of LDA to extract topics discussed by user. It calculates topic semantic coherence by presuming the ratio between topic and background words is same. Here is the formal graphical representation of TLDA. In Twitter LDA, per word topic assignment is denoted by Z. Alpha is the Dirichlet parameter, psi is the topical interest, gamma and pi is the latent value of common factor respectively. Theta bk and theta kw denotes background word distribution and topic word distribution respectively. W is the desired word here. As topic word distribution set is denoted by theta kw, here each word is implied by topic n is analyzed from theta kw and theta bw. When latent value y is 1, it verifies that the specific word is from theta kw. dt indicates the number of times a word in user SI's tweets assigned in topic T. These are the top relevant topics of some tweets. Here, table 1 represents some word topic distribution after applying Twitter LDA in our experimental dataset. Topic 1, topic 2, topic 3, and topic 4 denotes the topics about food, entertainment, technology, and sports, respectively. Recency score. Recency score is used to calculate users' most recent activities as they are the most likely matches with users' current topical interest. It is denoted by mu, ranging from 0 to 1. The formula mu, where age is denotes the amount of time passed since the activity occurred. Transition matrix. In mathematics, the transition matrix is a square matrix used to describe the transition of a Markov chain. Each of its entries is a non-negative real number representing a probability according to Wikipedia. It is also called a probability matrix. Here, transition matrix is denoted with PT, which implies the probabilities from follower S to friend Sj for any topic T, where for calculating transition matrix, the number of tweets published by Sj on those topics is divided by the sum of the number of tweets published by all of the SI's friends. Then the answer is multiplied by the similarity between those two users SI and SJ. Number of tweets published by SJ is denoted with psi. Similarity can be calculated by the probability of subtracting the differences of both users' interest in that specific topic from 1. Connection trust calculation. We also measure connection trust CT between two user I and J, as where the set N indicates the neighbor of user I. Connection strength. Then for measuring the overall connection strength, we consider the both transition matrix PT and connection trust CT using these equation. The controlling factor gamma and beta balances the above factor of two factors. Gamma plus beta is equals 1. Topic sensitive temporal page rank. With the transition probability matrix, the teleportation vector defined, the topic specific temporal page rank can be calculated, where TRT is the user's topic specific rank, ET is the teleportation vector, and gamma is a parameter which is greater than 0 and less than equal 1 to control the probability of teleportation. Now, here is a brief template of our algorithm TTUID, that is topical influential user detection 1. I am giving you a brief walk through our work in algorithm. The first step is finding the top trending topics. From line 10 to 15, it identifies top k trending topics at each time interval ik through the procedure top k trending topics. Here it computes and adds the trending score sigma for each topic t to a priority list of size k. It then returns the top k topics based on their trending scores. Next, the algorithm computes the recency scores of each activity performed by the user U in G from line 3 to 4. It then measures the transition probability PT, connection similarity sigma t, and weight of the edge WT between a user UI and 10 other random non-follower users of UI in line 5 to 7. Finally, it lists the top R influential users related to Q by executing the modified Twitter algorithm, which is from line 8 to 9. We use Twitter dataset named Snap Dataset, Stanford Large Network Dataset Collection, published in 2014. We randomly choose users and consider their tweets from June 15, 2009 to June 23, which covers different trending topics. This table represents the top 5 trending topics from June 15 to June 23 in 2009 with 3 days interval. This table indicates that these topics are mostly popular in Twitter within these days according to public interest. About 81,000 tweets were posted regarding Iran election in just 9 days. From 15 June to 17 June, there are approximately 36,000 tweets, 34,000 tweets and 12,000 tweets about Iran election, Microsoft and tornado respectively, which are the top topics. In second time interval, topic swine flu's trendy score has increased and it shifts up to second position. We can see that topic Microsoft dominates in first two time intervals but is not included in the last time interval. Here it shows of different topics during a specific time period using both Twitter rank and TTUID. approaches from June 15 to June 17. Here, the query set is Q, Iran election, Microsoft Tornado, which are the top three trending topics. We perform our experiment on those users who posted at least 20 tweets from total query set. Here, Ramini is in the second rank in Twitter rank, but it shifts down to fourth position in TTIUD approaches because Ramini has less common neighbors with these users in list than Iron and Lewis. It represents the influential user score of some top users from 15 June 2009 to 17 June 2009 using both Twitter rank and TTIUD. This table is for the second time interval which represent the rank and score of users from June 18 to June 20. For this interval, the query set is Iran election, swine flu, and Microsoft. Here, Bob obtains the first rank in Twitter rank method, but he shifts down to third rank in TTIUD approach. We also notice that Mike gets second position in TTIUD, but he is not among top 5 users of Twitter rank. It represents the influential score of some top users from 18 June to 20 June using both Twitter rank and TTIUD. Similarly, this table represents those users and their score from 21st June to June 23 in 2009, where query set is Iran election, economy, and swine flu. Here, top 3 users are the same for both Twitter rank and TTIUD, but there is a new user named Darian ranks ninth position in TTIUD. Coming to the conclusion, we have analyzed those users who achieve their influence over a certain time period for understanding what behaviors makes user influential. We also tried to identify influential users who show their interest toward a specific query on multiple topics at different time periods by emphasizing more on users' recent activities and their connection with other users. We also take into account the effect of influence on not only focus on users' influence to the direct connection but also common neighbors of each users. In future, we are planning to consider the interaction, mention or share, influence and also find out the query-oriented influential user on different local community and how they differ. Thank you for paying attention to our presentation. For any query, please contact to the given mail regarding this work.